Okay, so we'll be starting with in this video we'll take a look at how you can test the motors and the HC05 Bluetooth module with the D0 Nano board and the PCB that we have provided. So make sure that you upload your zip file on the D0 Nano board first. Get the uploaded version of the board here. Then take your PCB before you connect your D0 Nano board and power it on. Make sure that the buck converter, that is this blue thing, is set out to 5 volt output. That is, these two terminals should give 5 volt output. The switch is off, the connectors are properly connected, the negative is connected to the negative side of the battery and the positive is connected to the positive side of the battery. And then finally this 2-pin connector that we soldered in the first video, make sure that you connect this Relimate connector to your D0 Nano board before assembling. So the stud side should be facing inwards, that is inside the board. So if you see closely, the stud side I am putting in here. When I put in, it will latch onto it. So once this is done, now you can put the board into your PCB. While putting the board into your PCB, take a look at how I am orienting the board. The USB side or the connector side is facing upwards, so there is no tanglement between things. Now once done, align the headers. Once the basic alignment is done, you can start pressing. During some initial iterations, you might need to apply a little bit more force, not too much. Make sure that it is properly inserted from all the sides. If it is not, there will be loose connection and you won't be able to figure out what problem is causing it. Okay, so once done, this is your board ready. Now coming towards the motors. So these are the N20 micro gear motors that we have provided. These come with a small JST connectors, which are this things. You can plug one of them right here. Check the orientation of the connectors. They have a small slot here that you can maybe see in this video. So yeah, so they have a small slot here that goes inside these connectors. Okay, yes, so once connected, these two are the motors. The black thing that you see behind is the encoder. Encoder will give you pulses based on which you can calculate how much distance or at what speed the motor is rotating. Along with the motor, you will find some more accessories, that are these wheels that are supposed to be the wheels of the robots, and finally these two brackets. So these two brackets will help you mount the motor properly on the base of your robot. So something like this, along with nuts and bolt, you should be able to mount it clearly. So how to mount it and what to mount it is straightforward. So I'll leave it up to you to design your chassis and mount it properly. Now coming back towards the connection, the JST connector once plugged in, if you might feel some resistance if you plug it the other way around. So don't try to plug it the other way around. Check the orientation, check the gap in the connector and place it accordingly. Once done, you will see two of the smaller headers, or these two, on the JST connector itself, on the PCB itself. Now take this connector and try to place it in. So it will look something like this. If you notice, two of these connectors are flipped in direction. So if this is in X orientation, this is inverted by 180. So now I will plug this in. Okay, once done, check if the connector is properly connected. Now setup should look something like this. Okay, now once this is connected, what we need to do is we need to establish, since our D0 Nano board does not is not capable of directly providing the amount of current and voltage required to drive these motors, we'll be using something called a motor driver. So you can read more about the motor driver, but since we have connected these motors directly here, what we need to do is we need to establish a connection between the PCB and the motor driver. On the motor driver, if you look closely, on the bottom side, they might have written out 1, out 2, out 3, out 4. To know the connections on the motor driver, you can refer the sheet that we have provided. The photo, you can refer to the photo. Here we have written down to connect out 3 and out 4. That is written to the motor 2 connector, that is here. Similarly, for out 1, we have to connect it from here. And finally, the upper one is to the motor driver supply. Okay, so let's go. So this is MTR1. MTR1 is supposed to be connected to motor 1. So what we'll do is out 1 and out 2 on our motor driver, this is out 1 and out 2, we will be connecting it to here. So for now, I will take two jumper cables, male to male jumper cables. This you must have in your packet, and I'll unscrew this. Typically jumper cables is not a great option to select for a to provide power to a motor, but since our motor consumption is not that high, we can get away with it. But if you have ribbon cables or something better, then I would recommend going with it. So yeah, so I'll be screwing this in. Make sure that the connections are tight, because this is power connections. If one of these gets loose, it might cause damage to your bolt. Okay, once done, see, this is loose, so I might need to tighten it again. Okay, so check the connections, ready. Now we'll connect this to out 1 and out 2 on the motor driver, that is on the left side. You can connect it to out 3 and out 4 as well, but just make sure that each motor is connected to its respective pair. That is, you can connect out 1 and out 2, but not out 3 and out 1 to the same motor. Okay, so okay, this one you see is loose, so I'll tighten it up again. Okay, so this is out 1. So this is out 1 and out 2 properly connected. Now as we saw in the photo, we'll be using out 3 and out 4 to connect to the motor 2. So I'll repeat the process. I'll get 2 jumpers and connect it to out 3 and out 4. Okay, repeating the process again on this side. If you just invert the direction in which the motors are connected, that is, for example, if you connect the first pin of motor 1 to the out 4 instead of out 3 or out 1, then it might just invert the direction, invert the forward and reverse direction. So that is something that you'll have to check. You can handle the change by software wise or by rewiring the motors. Depending on which stage you encounter the error, you might handle it differently. Okay, so this is how it should look like. I have 2 motors connected. I have both these motors going to my motor driver. Now finally I'll take the 6-pin connector, this one, which will connect to the onboard element connector that you see here. So the middle one, I'll orient it correctly. It only goes in one way. Same for the smaller JST connectors, both of them only go in one way, so the chances of you inverting it are less. But while connecting here, connecting to the motor driver, these are the PWM and input pins, input digital pins, through which you will tell the motor driver what you want to do with the motor or what type of signal you want to replicate at a higher voltage. So hence the orientation should be checked. If you check the pin out here, here it is written enable B is the first one, enable A is the last one. So now on my motor driver, I'll check the names. Here if you see, enable B is the last one here. So according to my connector, enable A is last one, and here enable A is the first one. So enable A which according to our pinout is yellow, should be connected to the first pin, which according is green, should be connected to the first pin here. So find a gap. It might be a bit tight to get in, but press it in and it should be okay. So now if you check the enable A of my motor, okay, is connected to enable B. So yeah, I have inverted it. So I'll remove it again. You have to be careful, otherwise you might give the wrong signal. It won't blow up your PCB, but it will just give the wrong signal. That is not what we want. So yeah. So now if I check again, according to my pinout, enable A is the last one here, and the last pin from here is black, which goes to the first pin here, which is enable A. So verify the connections again. You have to be careful about these connections. And finally, the most important part, there is a motor supply connector that you can spot, this one, which if I look at my PCB is here. So I'll take two another jumpers and I'll give it to the motor driver. That would be the input supply for our motor driver. Now the internal working of the motor driver is something that you should look onto by yourself. Okay, so this one is a little bit bent. Tighten it up, check the connections, and now finally check the motor driver. On the motor driver you will see 12 volt and ground written at the bottom. Hope you are able to see it, 12 volt and ground. So the first is the 12 volt, which is where we will be connecting the positive, that is plus sign. This one, the one below, if you see properly or on the schematic, there is a plus sign here. So this is the plus one that I will connect to the 12 volt on the motor driver, which is the leftmost, that is this guy. So yeah. Okay, and the ground is the middle one, so negative will be connected to ground. Make sure that you do not invert this. Inverting this will cause permanent damage to all of your components. If you are lucky, just the motor driver, but still it damages the components and not a thing to do. Okay, so once done, we should have something like this, where you have two motors. Okay, so where we have two motors and motor driver connected. Each motor is connected. Check all of your connections. Now finally the HC05 module. Unless you connect this, you won't be able to control the motors. So the HC05 module I'll plug this in such that the module is facing inwards to the PCB. Check all the orientation, check all the motors to put the wheel on it so it's much more visible. I'll just align. So if you see the shaft, it is called a D shaft. It has a edge on one side. So you have to align that vertical edge with the vertical edge present in the inside of the motor, inside of the wheel, so that the motor goes in. So I'll try to find the edge. Okay, and then line it. And yeah, okay, this is motor 1. Now finally this is motor 2. Okay, now that everything is ready, I'll check my connection once again and finally connect my battery. Check if your battery is properly charged. Okay, once the battery is connected, power on. Okay, so once the connections are done, put your motor on a stable surface like this, which will help you to visualize the motors being rotated. Now check if the connections are properly made. Verify that the enable A, that is the last pin of this connector, is properly connected to the enable A on the motor driver. That is the red colored module that you have. Once it is done, you can verify your connection again and power on the motor. Once the power on the PCB. Once the PCB is powered on, you should be able to see two LEDs at the bottom of the motors, which indicates that the motor and the encoders are receiving power. Once that is verified, check if all the LEDs on the PCB are lit up. You should be able to see a continuously blinking LED here. This blinking LED indicates that the HC05 is looking for pairing. Once this is done, you should open the serial Bluetooth terminal app. This serial Bluetooth terminal app, you need to go inside the hamburger menu, go to devices. Inside devices, you need to select HC05. Once you select HC05, it should directly pair, and once it is paired, you should see a inconsistently blinking LED. Okay, in case you are pairing it for the first time, it might ask you for a pairing key. That might be 4 times 0 or 1 2 3 4. Once everything is ready, you can send a F and hash command to start the motor rotating in forward direction. Like you see here, if I put my finger here, the motor is rotating in this direction. Same goes for here. Now to rotate the motor in backward direction, you have to send the command R hash. When I send the R hash command, the motor starts rotating in opposite direction. If both the motors are not moving in the same direction, you need to check the wiring of one of the motors. That is flip output 2 and output 3 connection that we have put to the motor driver. Once this is done, you should be good to go.